Bienvenidos, Hushamdeed, and welcome to another supplemental video tutorial and solution set around Cisco Networking Academy's Introduction to Python course. In this video, we're going to be taking a deep dive look at Lab 2.1.4.7, where we're going to be working with variable names. Now, let's talk first about a few of the requirements that we have around variable names. Remember, the name must begin with a letter, and that can be either uppercase or lowercase, or the underscore character. And remember that the underscore character is considered a letter, and we're going to see some examples of this in this lab. Now, once you've got the beginning of the variable name with either an uppercase or a lowercase letter or the underscore character, we can have letters and digits throughout the rest of the name. In other words, numbers inside that name. And so that's what we're going to start working with right away, are variables. And let's take a look at Lab 2.1.4.7. We've got an objective here where we're going to be working with storing values in variables of different data types. In fact, here it's going to be integers. And this is our story. So we've got Apple Land, and we've got some requirements here in our task. So we're going to create 3 variable names. As you can see, each of these variable names begins with a letter, either upper or lowercase, and in this case it's going to be lowercase letters, but they could begin with an underscore, right? To then be followed by other letters, upper or lowercase, underscores, or digits. In other words, numbers. So let's create our variables first here. So it says create the variables John, Mary, and Adam and assign values to the variables. And they need to be equal to the numbers that we have up here in the explanation. So we have John, and John is going to be assigned the integer value of 3. Now, remember, the equal sign by itself, when you write this out, the tendency is to say, oh, John equals 3. Try to avoid that. Try to say it like this. Either the variable name John is pointing to the value 3, or the value 3 has been assigned to John. Because when we talk about equality, right, and from all of our mathematical training in the past when we were younger, we see an equal sign, and that means, oh, this is equal to that. But in Python, a single equal sign does not mean that. It doesn't test for equality, right? The single equal sign, the operator, the single equal sign as an operator is the assignment operator. I'm assigning a value to a variable, or I'm pointing a variable name to a value. Excuse me. And I'll talk about the pointing to here in just a second. So let's finish out our variable names. I've got Mary, and Mary has a total of 5 apples. Is that right? And Adam, 5 apples, and Adam has 6 apples. So there are the 3 variable names with the values assigned. Remember, we could have a variable name that starts with an underscore, and it could be Bob, and Bob might have 10 apples. It could start with 2 underscores and then be Bob, and those are different variable names right there. And he has 20 apples. Now, we're not going to be using those right now, but we will come back to them. I could have underscore 99 underscore Bob, and he has 100 apples. And as we'll see, those are all valid variable names. A quick way to check this is let's copy all of this, and then let's step out to IDLE, the Integrated Development Learning Environment. And I'm just simply going to paste all of this in. And it didn't like the fact that it was, when it pasted in there, it didn't take everything as its own individual line. So let me just show you the underscore Bob is 10, and that's great. Underscore Bob is going to be pointing to 20, or assign the value of 20, underscore 99 underscore Bob, and we assign that the value of 100. And as you can see, if I was to say underscore Bob, we get the value that we have assigned out. Again, the multiple statements error that we received here is when I pasted from the buffer, it took it as all one contiguous line instead of individual lines. But again, these names are valid as variable names. And as we move through the course, we'll talk a little bit more about why you would use the underscore, or why you're seeing things that have underscore, underscore, and then some name, and then underscore, underscore, like main. And so we'll get to that later on. So here are the valid variable names we have so far. So now that we have stored the numbers in the variables, we're going to print the variables on one line and separate each of them with a comma. And here's where there may be a little confusion. So let's clear that up. I'm going to say print, and let's go ahead and just say John, Mary, and Adam. Now, you may be interpreting the separate each of them with a comma as putting the comma in here to separate the variable names. Now, if that's how you've interpreted it, this is what your output is going to look like, 3, 5, and 6. My reading of this is that when the 3, the 5, and the 6 are printed out, there needs to be a comma separating those values. So we're very familiar already with the keyword argument SEP. And so I'm going to change that default SEP value, which is a space, which is represented in the print function when I use that comma. It gives me the default separator, which is a space, and we see that down here. I'm going to change that. And what am I going to change it to? Well, I'll use double quotes. Again, you could use single quotes here, you could use double quotes, but I'm changing that to a comma. So now let's rerun this, and we should see 3, 5, 6. And we do. So we've met that requirement there. It says now create a new variable named total apples, equal to addition of 3 of the 3 former variables. Now remember, we're doing addition here, and we're going to create a new variable name called total apples. Now, what I've just done right here with this variable name creation, it's called camel case, where I begin with a lowercase letter, but then the different words that might be in the variable name, I capitalize the beginning letter of the subsequent words, right? So if I was to say total Granny Smith apples, that's a kind of apple. So that would be camel case. Again, they're asking for this. I put the Granny Smith in there to show you what it would look like when there are multiple words that we're trying to work into our variable name. Now, you might be wondering, okay, well, is there some sort of standard around variable names? And there is. And we have that in what's called PEP 8. Now, PEP stands for Python Enhancement Proposal. And this is just simply the 8th one. There are many of these. You can see here that Guido van Rossum, the creator of Python, is one of the authors. But if we were to roll down a little bit further here, we would see that we have class names, variable names, function and variable names, right? So it talks about function and variable names, and excuse me. And it says that the name should be lowercase with words separated by underscores as necessary to improve readability. Variable names follow the same convention as function names. And so again, we're dealing with variable names. And the guidance based off this PEP is that the function name should be lowercase and that the words should be separated with underscores. Now, here's that mixed case, the camel case I just showed you with Granny Smith apples. It's allowed only in contexts where that's already the prevailing style. So again, it's more of a recommendation than a hard and fast rule. And it's going to come down to personal preference, or maybe the project that you're involved in has a standard defined, or maybe the lead programmer has defined some other kind of a standard. But if we were to follow the PEP 8 standard in the lab, sorry about that, let's get back over here. If we were to follow the PEP 8 standard, the total apples, which I'm going to go ahead and set to John plus Mary plus Adam, that would be total underscore apples. And that's kind of what they're referring to, right? Keeping it all lowercase with underscores, delineating the different words, Mary plus Adam. And if we had that longer name, it would be total Granny Smith apples. And again, this would be John plus Mary plus Adam. And if we were using the PEP 8 recommendation, it would be total Granny Smith apples, just like that, right? So we've seen a number of different ways that we can achieve the exact same goal. And again, it's going to be either personal preference or the legacy code that you're working with. So it is up to you, but know that PEP 8 is out there, and we will be referring to PEP 8 many times throughout these tutorials because there's a lot of very valuable information in there. All right, well, we've created the variable total apples, and we also took a look at some twists and turns with total apples in terms of variable name construction. So now it wants us to print the value stored in total apples. Well, all I need to do that is to say, and again, I could pick any of the examples I have there, but we'll go with the one that they're showing, which is simply going to be total apples with a capital A. So let's go ahead and let's run this. And what you should notice is we get the 3, 5, 6, and then we get the total number of apples. Now, even though I've defined all these different variable names here that we're not using, it's okay because, again, the syntax is correct. We're not going to receive an error message, just like the variable names we created here with our underscores. We're not receiving error messages. It's just that we're not using them. Now, again, this is an example. I'm going through doing a solution set and kind of building on that solution set. So you would definitely want to clean this up for a final submission, but this gives us a good example as to how we have different ways to represent variable names and what the requirements are for those variable names. All right, so now it's asking me to experiment with my code, and we're going to be looking at this. Try to print a string and integer together on one line. So let's go ahead and do that. I'm going to say print the total number of, or I should say, let's say the sum total of apples between John, Mary, and Adam is. Now, I'm going to put a colon there, and you can see we're dealing with a string. So the question is, do I put total apples here? And now that's going to look funny, right? And you'll notice that we're dealing with a variable name, but we've got it inside the quotes. Let's see what this prints. So let's print this out. And you can see what happens here is it says total apples. Well, we already know that's not what we want. We want it to print out the total number of apples. So just like the print statement here, notice that the variable name is not inside the single quotes or the double quotes or the triple quotes. But what would I do to put a space, right, outside of the quotes and then say total apples, right? So I basically put a comma, and then I put the name of the variable. And let's see if it prints all of this together for us now. And so in other words, we should see the sum total of apples between John, Mary, and Adam is 14. So we've walked through a couple of examples with addition. We've talked about the variable names. And just because we're doing addition here doesn't mean that we couldn't do multiplication as well. So let's say multiplied underscore apples. Now, what would that be? It would be John times Mary times Adam. And if I wanted to print that up down here at the bottom, we would have a print statement that says the, and with multiplication, I'm not sure the multiplicand, I can't remember what it is with multiplication, but we'll just say the total of the apples multiplied together is, and we already know what we need to do. We come out here and we say multiplied underscore apples. Again, following that PEP 8 variable name convention with all lowercase and multiple words separated by an underscore. Now let's run this one last time and see what we get. And there we go. The total of the apples multiplied together is 90. So again, I encourage you to work on some different approaches here. So let's copy this. Let's come back out here to idle, and let's drop this in. And the final thing, and we're going to give ourselves some more room so we can see everything as 1 there. So the final thing we're going to talk about is how we would check to see what data type we're dealing with. And remember, we talked about variable names, and I said it points to a location in memory. So if I was to say X is 9 and Y is the string, the string data type of 9, when I say ID, and this is going to show me the location where the variable X or the object X resides. And again, that's a numerical representation of the location in memory where that value, that integer value, is being stored. So how do I know that it's an integer value? Well, we can use another built-in Python function called type, or named type. And I simply type out type, open parens, and then put the name of the object in the parentheses. And it's of class integer. What about Y? If I say ID Y, it shows me the location in memory that points to that value. Now, what if I want to know the type? Well, I simply say type Y, and as we can see, it's a string data type, right? And that's how it's represented. So that's a quick and easy way, if you're not sure, to double check what data type it is that the variable is referencing or has been assigned. All right, well, that is our solution set right there. Let's see, does it run here? Let's hit F5. We're going to save this guy off as 2.1.4.7, 2.1.4.7.py. And we're going to click Save. And there it goes, 356, there's our 14, we get the sum total. So everything looks great. We now have a file that we could refer back to later on, or that we can continue to manipulate in order to practice our Python skills. All right, well, that is going to do it for this supplemental video tutorial and solution set on Lab 2.1.4.7. All right, stay healthy, stay happy, and I will see you in another video here shortly. Have a great day.